So let me go over what you'll see in today's video. What you'll see is the continuation on this design. Now we got the design going before, but now it's taking the data, simplifying it, and then creating something like this. These are struts that are developed, and these are the unique members that you'll see within this design. And what I did is I created the form where I subtracted this portion that is kind of the smashed end portion. Then we also created the perforation or the hole for it, and then we create the washer at the end. I'm going over all of the steps. This is closer more to fabrication. Once you have your design, you can take additional steps to create these members that are developed so you can see everything from beginning to end. So with that being said, if you want to download this, check out my website, capettidavid.com. You'll be able to download both the beginning portion and this fabrication portion. I also have other resources, so if you'd like to support my work or if you'd like to find other resources that can help you understand parametric design, check out my website and let me know if you have any other questions. Otherwise, stay tuned. I'm going to be going over all of it here, and let's jump right in. All right, so on the last video, we created this whole design, and what we didn't do was try to figure out how to develop this completely. Now we did add the dimensions, so we have that here, and we can change the size so we can see what the different dimensions are for the different structural members. So we have these that are 12, so all of them are going to be the same. The ones that are here, the diagonals, they're also going to be the same. And so we have 1, 2, 3, and then 4 unique separate sizes that we have. And so the idea here is, can we separate a list of the unique strut members? That way we have that list and we know the dimensions we need to cut, and we don't have all the redundant ones. So that's what I'll be showing you here. Is what I did was I brought out all of these struts. So let me just hide the dimensions. Let me also hide the pipe. So starting with the wireframe, every single one of these curves is a single curve. It's not a polyline where they're all joined together. Now with this, what I did was I plugged that into the length. Now what that's going to do is basically do the same thing that the dimension does, but it's going to give us a list here of the numbers, all of the lengths for the entire set here. So I'll copy this and show you that if we use a panel, we have here, let's say if it shows us how many. It has 98 separate line segments, and look at all of the decimal points that it has. So what I'm doing is I'm simplifying this entire list, number one, by sorting it from beginning to end. So with this component, I plug in all of the lengths into the sort list. I plug it into the keys input, and then what it does is it outputs the entire list organized. Now notice here that the first one is 16, then 12. Now when we plug this in, we have the entire list here, and it's been organized. So by 11, 12, 16, and 22. So it does it in order here. So what I wanted to do was take this list, which is the same thing as this one, and then round it to 3 decimal points, because here we have too many. So I just wanted to go 705. And so what I did was bring in a component of this number. This number was plugged in here, and I created a expression where it says round 3, or x, 3. And what this does is it rounds the number down to 3 decimal points. Now we can also change that if we wanted to just round it to 2 decimal points, we can do that. And so once we round that length to a smaller number, then we can isolate each unique set. So that's what this one is called. It's called delete consecutive. Once we plug in the entire list from 11.705, 12, 16, and it will get rid of the things that are redundant and just show us here that we have the segments that are 11.7, 12, 16, and 22. The cool thing is that even if we go out here and we change this, so let's say we wanted to have 12 subdivisions, and let's even go 16, even here going to 8, and then maybe doing 6 of these. What this will do is the same thing. It'll sort the list, round them off, and show us here that now we have segments that are 5.8, 8, 9, and 11. And now we can know that we're going to fabricate them at that size. Sometimes they're going to be too big. Sometimes they might be too small. So this is also a guide for you to understand how big your design is going to be and how big each structural member is. So what we're going to do now is take this data and create each strut as an example of what the strut is going to look like when it's created here. We're just going to be creating an example for each one of these, and that'll help us visualize this design a little bit closer to what it's going to look like in the end. All right, so with these 3 or 4 different sizes, what we're going to do is create a line segment. So SDL, starting, I'll go here to construct point. Starting here, the direction is going to be in the X direction. And the length is going to be all of these. So now when we plug in more than one number, it's going to be creating 4 different line segments here. So what we need to do is move them. Since we know it's 4 of them, we can do a series. So we'll do move. In which direction? In the Y negative. And we're going to be using a series component with 4. Now we can step it here. The first step, we can do 3.5. And then from there, step them more. So the first step is kind of, moving it away from the structure. And this is how far away each line segment is. So the cool thing here is, like I said, we'll go back here, change the subdivisions. We'll go to 10. Change this to 10. And now you'll see that it'll change the size on here. What I like to do is go to wire display hidden. This way we can kind of use, this part of the script as the example for each strut. So now what we'll do is we need to, when we create a structure, this is going to be the point where the hole is. This is the point where the hole is. So it actually needs to be extended by about 1.5 inches to 2 inches. So what I need to do is bring in the extend. And I'll extend by 1.5. both the start and end of each one of those. So we have the start, and then we have how much we extended by. Now here, what we need to do is turn this into a pipe, caps, I like to use flat on this one, and then the radius is going to be how big your strut's going to be. Mine's 0.5 or half an inch, but if it's half-inch diameter, then we actually have to divide by 2. Otherwise, it would be 1-inch diameter. Now, notice that this doesn't really show us what the strut's going to look like. So what we need to do is create that little bit that is subtracted. To do that, we'll bring in the endpoints for both the non-extended and extended curve. Create a line segment between the start and start, creating those line segments, and then the end and the end, creating another set of line segments. So what we'll do to one first, we'll be doing to this one as well. So let's go here to offset, curve, and we'll actually be offsetting it by half. So the radius amount is what we offset by, and then we offset by the negative amount of that. Again, here. Now we can loft these two. And notice it creates kind of a surface there. Now what we need to do is take this and move it up in the Z direction by a small amount, 0.125, that's 1/8 of an inch, be a little bit less. And then extrude this up in the Z direction by the radius, because it will always intersect it. And now let me see if we can mirror this using this plane in this input. Now with these two, we can subtract. Now let's decrease this number here. We can subtract that, so we'll go to difference. Well, before we do that, let's actually hide. Just clean this up a little bit first. Okay, so what I'm doing here is I'm double clicking on the output to get a relay. Although this kind of goes like this, makes it a little bit easier. And then this number, I'm trying to clean it up so it's easier for you guys to see. Okay, all right. So now let's try to do the exact same thing we did to this one, but to this one down here. So we'll take all of this except for the slider. Why? Because once we do that to one, we can do it to the other one. Except for I didn't take this. Let's try that one more time. Everything except for the slider, including the relay. So I can use the relay as the input and get the same thing going on the other side. Now, this side is the one that changes, so it's more impressive in the sense that you can see that it does it to each one. So now here is where we can clean this up a little bit. So delete the relay and now hide the input of the sliders or of the wires that are kind of in the way. And that happens when we bring in some, or we tie some sliders in from, let's say, the beginning. Okay. All right, so now we take this and we do a difference, solid difference between this pipe it deleted the bottom part. Deleting the top part. Let's see if that works. Yep. And then same thing here. All right. Maybe the only thing that might be different is this. Maybe 0.75 is about how much. Yeah, it's 0.75 on each side. Okay, for now, let's disable the preview on everything except for the struts at the end. So this is kind of what they would look like. Now, obviously, the one thing I would say, actually, hold on. Because this is just moved up and extruded. This, I mean, it doesn't have to happen, but this would be a really good thing to show is this angle. Let's see if it shows up here. Oh, it doesn't work with the pen. Okay, let's try it without it. So all of this is copied and this Boolean different part. It's not necessarily enabled yet. Let's just pretend that we're still on this one. We brought this up. This is extruded up, but instead of extruding it up, what we're going to do is move it up again using the same vector. Now here on this one, we're going to evaluate. So let's go here to evaluate surface. Bring in a construct point component. And if we parameterize, we can go here to 0.5. Both in the X and Y. And then see that it's point in the middle and 1 here. Same for all of those. So we can now scale non-uniform this surface relative to this plane, and we can just do 1.100 scale in the X direction. Actually, it's going to be the Y direction. So now the idea is that rather than extruding those, we can loft this one and this one. Cap holes for the input. So notice that all I did was, rather than extrude it up, I copied a surface up, scaled it using this. Now I'll clean it up a little bit. And now what we need to mirror to the other side is going to be the same one. So this is taken out. This is mirrored. And now we are subtracting both of these. So now we can disable the preview and enable this one. Now it looks a little bit more like what a strut looks like when you smash the end here. And actually there's something else that we need to do. So this cleans this up. Now we need to do it to the other side, but before that, I actually want to show that if these are the line segments, these are the start and end points, we need to create a plane there. So an XY plane at both the start and at the end, using circles. Why? Because we're going, or cylinders. Actually, let's use circles for now. So at the start point, we'll be creating, the radius will be 0.125 divided by 2, because we want to be able to use the diameter. So let's just say 0.5, no, it's gonna be 0.125 for the radius here. And now we're going to be creating a surface here. Boundary surfaces. Now I'll be taking this and extruding it up. So extrude. In the Z direction. Actually, first move. We'll do 0.5. And extrude. If we extrude by 0.5, it'll go up. But if we go negative, it'll go just to where it was. And if we do ×2, it'll actually center it from that location. So ×2 multiplied by 2. And now this becomes 0.5 from here to here, 0.5 from here to here, 0.5. So we can take this and divide by 2 to make it the actual length. So technically we can subtract from this, but this is incorrect in the sense that if we extend, see here, by 0.5, we would actually need to smash a little bit more to the right here. So this is going to be centered. So let's do that part, because if, check it out, if this surface is created from these two, then we can extend those And we'll extend it by the same amount as this, 0.5 and 0.5. But notice that we only need to do, I think, yep. So the start needs to have 0.5 and the end 0 because it needs to stay the same. And so we'll do that both to this one and this one. And now we can loft those two. Notice that now that extension this way becomes the same extension this way. Why? Because that's the part that you smash to be able to create this design. So let's disable the preview on all of this stuff. And also clean up some of the script here. All right, so technically we've only done that to one side. So let's do that also to the other side where we extrude it. So now we have these that we'll use to subtract. And in the same way that we did that to this one, no, we can do that to the other one. So what we'll do is this. And technically, if it's 0 and it's always going to be 0, I can internalize data. That way it's in there as 0, but we don't need to, keep the slider there because that can actually introduce, an issue if I move it. All right, so taking all of this and copy everything except for the sliders, unless this slider is going to be the same. Maybe it's different. For now, we won't keep it, and then we'll slide it down, tap Alt, and we'll do the same thing to this one. But we won't do the difference part yet because we need to just show that we were bringing back these forms, and now we can add them to the subtraction of the struts here. All right, next is subtracting. So it's subtracted those. Let's subtract the holes here. Now we need to flatten the input here. And I'll disable the preview on those and those. And so now if we bring in a custom preview and a color picker, we can see that now we have the struts here. Now the idea is that this extension no, this is not it. The extension of the, let's see here, this one, the extension, so how much more you add after the strut, let's see. Having some issues there. If we extend it more, let's say 0.75, it'll do 0.75 this way and 0.75 this way. Now, I think the issue here is that we're not going to flatten the input, but we will get rid of this. I think what we'll do is move. See those, it works. So if it extends that way, oh, I know. What we can do is extend. So we said that these actually extend by 0. But maybe they extend on the other side by just like 0.1. And then 0.1 on this one. So that way it extends a little bit more this way, but it always works. So I was gonna try something else, but I think that fixes the issue. Yep, exactly. Okay, and the last thing is I actually want to subtract the holes as like a step after. So this is kind of the idea, is that this subtracts the form and this subtracts the hole. There it is. Okay, so what I wanted to show is if you extend one side or the other, this is actually going to extend and smash one of the ends, depending on how you're overlapping them. I think the best way, like if you extend by 0.75 on each side, this will ensure that you can actually manufacture it pretty easy, but you can probably go down to 0.5 and that would probably be enough. But that's one. Then the strut size, 0.75. And this can also be tied to how you develop this here, right? So if we have this pipe at 0.75, you can actually see what that would look like and how many separate individual ones you have. Now let's change, if we were to change the subdivisions, notice that we got different sizes. So if we do 24, well, one is going to be larger here. All right, for the last thing is I want to show, now that we created the struts here, all right, so these forms we moved up by a little bit here. So I'm going to copy that because I want to move circle up to that point. I want to offset it. By 0.125. It typically goes to the outside, which is okay in this case. And then we're going to offset it one more time to the outside. And then we'll do 0.25 which means it's going to be 1/2 inch. Now here, we'll use a boundary surface. Now they're overlapping, so we either graft one set for it to work, or you can flatten the input. This is a little bit cleaner in the sense that now we can extrude this up by a little bit. Just copying a slider here. All right. So what we need to do now is, lastly, hire the wire display on this one. And then a little bit of a different color there. Okay. So now we'll finalize this. What I'm going to do is clean this up, add labels, and share it with you guys. So this is going to be basically an addition to the last script. This shows you a step further, right? What we did last time was come up with the design, figure out how it was going to be laid out. It has some diagonals. And then now that we're fabricating it, we know the size in general using the dimensions that we had before. Then we took all of that information and we simplified it by understanding what are the smallest or what are the unique strut sizes that we have in the design here. So once we brought it and we did that within this portion, then we can take that data and create a separate set of unique structural members that are developed, and you can see what they're going to look like before you develop the whole thing. This is actually something I've done before. I have not shown the whole process, so I'll be manufacturing and creating something like this with some of the stuff that I have, so I'll be sharing the process later on. But for now, I'm showing you not just the design portion, but also the fabricating part, which is using the data and moving it around to create examples like this.